Hello friends, welcome back to my YouTube channel Maths by Samit Deshmukh. So in the last two videos, we have seen definition of matrix, algebra of matrix and types of matrix. But today we are starting actual syllabus of class 12th. So if you are new on my channel, subscribe the channel and hit the bell icon to get the notification of newly uploaded videos. So now we are starting syllabus of class 12th. So here first article from this chapter is elementary transformation, and the next important thing that weightage given by the board to this chapter is what? 6 marks. Now elementary transformation, this elementary transformation are nothing but three very important operations, and these operations we have to apply while solving the example. So try to understand these three operations which we have to perform on the element of row or the element of column of the given matrix. So now our first operation says that we are able to interchange the element of any two rows or any two columns of the given matrix. So we are able to interchange element, means interchanging element of two rows or any two columns. So let us try to understand this first operation by considering one example. Let A is one matrix, let its elements are say 1, 2, 5, 6, 8, 9. Now if we want to interchange element of any two rows, suppose that we want to interchange the element of R1 and R3, then it will be denoted by this notation. So R1 double implies R3. This notation says that we are interchanging element of R1 and R3. So see what we will get here. So if we are interchanging element of this R1 and R3, so don't disturb to element of R2 because there is no operation on R2. So interchange the element of R1 and R3 means write down the element of R3 in R1. So element of R3 are what? 8, 9, which we have written in R1, and element of R1 write down it in R3 means third row. So what are the element here? 1, 2. So here in this way we have interchanged the element of what? R1 and R3. So this operation or this result we have got due to first operation of elementary transformation. Hope the idea about how to use this operation is very clear to you. Now when to apply to get our required result while solving the example, just now we are trying to understand what are the three elementary transformation operation of elementary transformation. Now let us consider another example. Let the element of this matrix are 1, 2, 3, say 4, 5, 6, 7, 8, 9 are the element of this matrix B. And if you want to interchange element of any two columns, suppose that we want to interchange the element of C1 and C2, then it will be denoted by this notation, and see here what result we will get here. Now we are interchanging element of first column and second column. This is C1 and this is what? C2. So write down the element of C2 in C1, that is 2, 5, 8, and element of C1 into C2 1, 6, 7. Keep remaining element 3, 4, 9 as it is. Now here we can easily observe that these two matrices are equal matrices or not equal. Just we can observe that the corresponding elements are not same. So these two matrices are not equal. So it will be denoted by this notation, which is read as equivalent. Means whenever we are performing elementary transformation, means any one of these three operations, the new matrix which will be not equal to given matrix, so it will be denoted by this notation which is read as equivalent. Okay, so here also these two matrices are not equal, so it will be denoted by this notation which is read as what? Equivalent. So hope the idea about two important operations. So first important operation of elementary transformation is very clear to you. According to this operation we are able to interchange element of any two rows or any two columns, isn't it? And its symbolical representation is this one. Now let us discuss about second important operation. According to second important operation, multiply to the element of a row or column by a non-zero scalar. In mathematics, scalar means what? Real number. Means we are able to multiply to the element of any row or element of any row or any column by non-zero scalar. Means scalar means real number, means by non-zero real number, means the real number may be either positive or what? Negative, but it should not be equal to 0. So try to understand this operation by considering one example. So this is the example of first operation. Now we are discussing second operation. Let us suppose that A is one matrix and let its elements are 1, 2, 6, 7, and B is one matrix matrix, let its elements are 3, 6, 1, 5. Okay, so now here suppose that we have to multiply to the element of say R2 by 2. Let us see what we'll get. So it will be denoted by this notation. R2, our operation is on what? R2. And what operation we are doing here? We are multiplying to the element of R2 by what? 2. So it will be denoted by this notation, or simply it will be written as what? 2R2. Not necessary to write down this notation. Meaning of both the notation is one and the same. Its meaning is that we are multiplying to the element of R2 by which non-zero real number 2. So let us see what we'll get if we are multiplying to the element of R2. So keep the element of R1 because there is no operation on R1. We are multiplying to the element of R2. These are the element of R2 by what? 2. So 2 into 6 is what? 12, and here 7 into 2 is what? 14. In this way, new matrix which you are getting is denoted by this notation, which is read as what? Equivalent. Now suppose that here B is one matrix and we have to divide to the element of R1 say by 3. So it will be denoted by divide by 3, means write down it as 1 by 3 R1. We are dividing to the element of R1 by what? 3. Means in short, in this if we are talking about multiplication, in terms of multiplication, means we are multiplying by 1 by 3 to the element of what? R1. Or in other word, we can say that we are dividing to the element of R1 by what? 3. Or we can read it as what? We are multiplying by 1 by 3 to the element of R1, because 1 by 3 is a real number, and real number in mathematics is called as what? Scalar. So let us perform this operation on the element of R1. We are multiplying by 1 by 3, means in short we are dividing to the element of R1 by 3. See what we'll get here. If we are dividing by 3, here we'll get 1, here we will get 2, and here keep element of R2 as it is. So our second operation says that we are able to multiply to the element of row or to the element of column by what? Non-zero scalar, and this will be the notation if we are using this second elementary transformation operation. So very simple operations are there. First operation says that we are able to interchange the element of any two rows or any two column. Second operation says that we are able to multiply to the element of row or to the element of a column by non-zero real number, means non-zero scalar. Third operation is very important, because maximum times we are using this third operation while solving the example. Now see, the third operation of elementary transformation says that we are able to add or subtract to the element of row or column with non-zero multiple of corresponding element of any other row or any other column. So very important operation. Try to understand it very carefully. Now we are trying to understand this operation by considering this example. So one matrix we have considered here whose order is 3 by 3, are able to consider any matrix. Now suppose that here we required 0, here we will require what? 0, means first element of R2, if we want to convert it into 0, means our operation is on what? R2. Our operation is on R2, and what is the element of R2 here? 3. If we want 0, so from 3 we have to subtract 3. We have to subtract what? 3 to get 0 here, because to convert 3 into 0 we have to subtract 3 from 3 to get 0. So now this addition or subtraction can be done with what? With non-zero multiple of corresponding element of any other row. So now our operation is on R2, means we have to use the corresponding element of other row. Other row means of R1 or of what? R3. We have two choices. Our operation is on R2, means we have to use the corresponding element of any other row. तो other row कौन से है यहाँ पे? R1 एक है और R3 एक है, और हमें क्या subtract करना है? 3 subtract करना है. तो चलो 3 कहाँ पे मिल सकता है हमें? Let us check in R1. In R1, if we are using corresponding element of R1, if I am multiplying here by 3, so means 3 R1. So what we'll get? 1 into 3 is 3, and later on we have to take what? Subtraction, because 3 minus 3 will become what? 0. So here this addition or subtraction can be done with what? Non-zero multiple of corresponding element of any other row. Non-zero multiple of corresponding element. So which is the multiple here? 3. 3 is the non-zero multiple. ऑफ करस्पॉन्डिंग एलिमेंट, किसी और रो का करस्पॉन्डिंग एलिमेंट यूज करना है, तो हमने कौन से रो का करस्पॉन्डिंग एलिमेंट यूज किया है यहाँ पे, R1 का. मीन्स वी आर सब्ट्रैक्टिंग टू द एलिमेंट ऑफ R2 विथ नॉन जीरो मल्टीपल, विच इज द मल्टीपल हियर 3 ऑफ करस्पॉन्डिंग एलिमेंट ऑफ अदर रो, विच रो वी आर using here, R1. Is it clear? Let us see what result we will get here if we are performing this operation on element of R2. Keep element of R1 as it is, 1 2 2. Now we are performing this operation on element of what, R1. So two choices are there, either do some rough work. रफ वर्क अगर करना है आपको तो पहले R2 के एलिमेंट लिखो. व्हाट आर द एलिमेंट ऑफ R2? दीज आर द एलिमेंट ऑफ व्हाट, R2, 3 8 10, isn't it? And later on -3 R1, -3 R1. So multiply to R1 by what, 3, and then take this subtraction, isn't it? So R1 multiply to the 3, so here we will get 3 6 6, and we are taking subtraction, we are taking what, subtraction. So 3 minus 3 will become 0, 8 minus 6 will become 2, and 10 minus 6 will become what, 4. In this way we will get what, 0 2 4 here, isn't it? So in this way we have got the element of R2. Now another way, now as you are the student of class 12th, so orally also we are able to perform the calculation. तो oral कैसे करेंगे calculation, क्योंकि आपको oral की practice करनी पड़ेगी, ये सब चीज़ों में time ज़्यादा जाता है. So perform the operations orally. Now observe here, operation is on R2. So these are the element of R2, isn't it? Observe, our operation is on R2. So observe the element of R2 and multiply to R1 by what, -3. Multiply to the element of R1 by what, -3, and whatever may be the result we are getting, add that value into R2. So multiply to the element by R1, multiply to the element of R1 by what, -3. See what we'll get, -3 into 1 is -3, -3 plus 3 will become 0. Multiply by -3, here we'll get -6, -6 plus 8 will be equal to 2. Multiply by -3, 2 into -3 is -6, -6 plus 10 will be equal to 4. So again we are getting 0 to 4 here. Try to perform this operation orally, isn't it? So now in this way we have got 0 here. Now suppose that we will require 0 here. अगर यहाँ पे हमें 0 चाहिए तो हमें क्या करना पड़ेगा? Our operation should be on what, R3, isn't it? What is the element of R3 here? -6. We have to convert it into 0, so we have to add what, 6. -6 है तो उसमें 6 ऐड करना पड़ेगा तो 0 मिलेगा. चेक दैट, इज इट पॉसिबल टू गेट 6 हियर? यस, इफ वी आर मल्टीप्लाइंग टू R1 by 6, if we are multiplying to R1 by 6, we are getting 6 here, and whenever we are adding or subtracting, at that time we have to use compulsory, we have to use corresponding element of other row according to this elementary transformation. आप सिर्फ 6 के साथ एडिशन नहीं कर सकते, आपको किसी और रो का करस्पॉन्डिंग एलिमेंट यूज ही करना पड़ता है टू परफॉर्म दिस थर्ड एलिमेंट्री ऑपरेशन. नहीं तो आप बोलेंगे यहाँ पे सिर्फ +6 कर दो. It is not possible because our operation says that use the corresponding element of any other row and use any non-zero multiple. Here which multiple we are using here? 6. But here we have to take addition or subtraction because this element is negative, and if I am multiplying here by 6, here we will get 6, and 6 minus 6 will become 0. That's why we have to take what, addition here, because already this element is minus and here we are getting +6. -6 plus 6 will become 0. Now we are trying to perform this operation orally without using this method. Instead of using this method, let us try to perform this operation orally. Our operation is on what, R3. So observe the element of R3. These are the element of what, R3. We are using corresponding element of what, R1. R1 का corresponding element use कर रहे हैं हम, and we are multiplying to the element of R1 by what, 6. So multiply by 6. 6 into 1 is 6. 6 minus 6 is 0. Multiply by 6. 6 2s are 12. 12 plus 7 is 19. Multiply by 6. 6 2s are 12. 12 plus 5 is 17. In this way we have got the element of what, R3, using this last elementary transformation operation, isn't it? So hope the idea about how to perform this operation is clear to you. This operation can be performed on element of a row or column. As it stand, we have performed this operation on element of row. But while taking addition or subtraction with element of any row, we have to use non-zero multiple of corresponding element of any other row. If we are performing operation on column, so we have to take its addition or subtraction with non-zero multiple of element of any other column, isn't it? So these are three important operation. अब ये operation कैसे यूज करना है ये तो हम एग्जाम्पल सॉल्व करते वक्त देखेंगे, बिकॉज दे विल टेल मैट्रिक्स विल बी गिवन टू अस एंड दे विल tell that convert this matrix into this new matrix. So at that time, to get the new matrix, we have to decide which operation can be helpful to get our required result. तो जो operation apply करके हमारे required matrix के element मिल सकते वो operation हम use करेंगे. Means we will have three important operation. We will use it in such a way that we will get our what required result. So now using this three elementary transformation operation, we are solving the examples from our first exercise. Now see the example number first from exercise 2.1. So in some matrices are given to us and we have to perform the given elementary transformation operation. Means operation is already given in the example. That elementary transformation means the three important operations of elementary transformation is there. So operation is already given in the example. Just we have to apply that operation on the matrix. So observe the first example here. One matrix is given to us and which operation we have to perform? Interchange the element of R1 and R2. So here we have considered this matrix and now we are performing this operation, means we are interchanging the element of R1 and what? R2. So we will get a new matrix which is denoted by this notation, which is read as what? Equivalent. So now if we are interchanging element of R1 and R2, what will the element of R1? That will be -1 and 3, and element of R2 will be what? 1 0. Simply we can observe that we have interchanged the element of R1 and R2, and same operation we have to perform here in this example. Now observe the example number second. In this second example, when matrix B is given to us and we have to perform operation on R1. And what is the operation on R1? R1 minus R2. Means from R1 we have to subtract R2. So consider the given matrix and we are performing this operation, that from R1 we are subtracting what? R2. So we will get new matrix. Let us denote it by this notation. Already we have seen that this notation can be read as what? Equivalent. Now our operation is on what? R1. So keep the element of R2. We are not disturbing to element of R2 because operation is on element of R1. And from R1 we have to subtract R2. So 1 minus 2 will be equal to -1. -1 minus 5 will be equal to -6. We are just simply from R1 we are subtracting R2. So here 3 minus 4 will be equal to -1. In this way we have performed this operation on the given matrix. Now observe the third example. In the third example here, when matrix A is given to us, in which we have to perform this operation, means we have to interchange the element of C1 and C2, and in the matrix B we have to interchange the element of R1 and R2, element of R1 and R2, and later on question is what do you observe? First let us perform this operation and later on see what is our observation here. So first operation we are performing on matrix, and according to given condition we have to interchange the element of C1 and C2. This is C1, first column, and this is C2. We are interchanging the element of C1 and C2. Write down the element of C2 in C1 and element of C1 into C2. Means in short we have interchanged the element of first and second column. So here again perform this operation on element of matrix B. What is our operation? Interchange the element of R1 and R2. So 4 5 are the element of R2, shift them in R1 and write down the element of R1 in R2. So just simply we have perform which operation? Interchange the element of R1 and R2. Now according to our question we have to observe these new results. What is our observation here? 4 4 5 5 3 3 1 1 means all corresponding elements are what? Equal. So what we can say that the new matrices are equal matrices. So therefore we can say that new matrices are equal matrices. Now see the question number 4. In this question two matrices are given to us. A is a matrix and which operation we have to perform on the element of matrix A? 2C2 means we have to multiply to the element of second column by 2. Second matrix is B, and which operation we have to perform? Minus 3R1 means we have to multiply to the element of first row by minus 3. So let us consider this matrix A and perform this operation 2C2 means we have to multiply to the element of second column by 2. So here no operation is on first column, so keep element of first column as it is, multiply to the element of second column by 2. So 2 2s are 4 and 2 1s are 2. Here there is no operation on element of third column, so keep element of third column as it is. Now B is one matrix, and which operation we have to perform on element of R1? Multiply to the element of R1 by minus 3. So multiply by minus 3, you will get minus 3. Minus 3 into 0 is 0, and minus 3 into 2 is minus 6. There is no operation on element of R2, so keep the element of R2 as it is. Now second part of this question is find the addition of new two matrices. So therefore addition of these two new matrices, which is the first matrix, its elements are 1 4 minus 1 0 2 3, plus second matrix is minus 3 0 minus 6 2 4 5. Now we have to take the addition of these two matrices. We have already seen that addition of two matrices exist only if their orders are same. So let us check what is the order of first matrix. 2 rows are there and 3 columns are there, means its order is 2 by 3, and here also 2 rows and 3 columns means order of second matrix is also 2 by 3. Since both the matrices are of equal order, so we can say that their addition exists, and whenever we are taking addition of two matrices, simply take the addition of corresponding element. So here take the addition of corresponding element. 1 minus 3 is minus 2, then 4 plus 0 will be equals to 4, minus 1 minus 6 will be equal to minus 7, then 0 plus 2 will be equals to 2, 2 plus 4 is equal to 6, and 3 plus 5 will be equals to 8. In this way we have taken addition of two new matrices. Now see the question number 5. In question number 5, one matrix is given to us. So let us consider the given matrix. A is one matrix. Element of this matrix are 1 minus 1 3, 2 1 0 and 3 3 1. So which operations we have to perform on the element of this matrix? First operation is 3R3. So first we have to perform this operation and then perform this operation on the element of third column. So our first operation is 3R3. What is the meaning of 3R3? 3R3 means we are multiplying to the element of third row by 3. So there is no operation on element of first row and second row. So keep the element of first row and second row as it is. Now multiply to R3 by 3. So multiply by 3, 9, 9, 3. In this way we have got one new matrix. Again which operation we have to perform? C3 plus 2C2. Our operation is on C3 means third column. So keep the element of first column as it is, 1, 2, 9. Then keep the element of second column also as it is. Now perform this operation on the element of third column. Observe these are the element of third column and we are adding and in case of this addition we are using corresponding element of second column and we are multiplying to second column by what? 2. So observe this operation is on third column. So observe the element of third row. Here while taking addition use the corresponding element of C2 and multiply to C2 by what? 2. Multiply to C2 by 2 and whatever may be the result we are getting, take its addition with C3. So these are element of C2. Multiply by 2. 2 into minus 1 is minus 2. Minus 2 plus 3 is equal to 1. Multiply by 2. 2 into 1 is 2. 2 plus 0 is 2. Multiply by 2. 2 into 9 is 18. 18 plus 3 will be equals to 21. In this way we have performed both the operation on the given matrix. Now see the question number 6. In this question, one matrix A is given to us and first we have to perform which operation? C3 plus 2C2 and then perform the operation 3R3. And later on, question is what do you conclude from example 5 and example number 6? Example 5 already we have solved here. So if you observe both the example, check that both the matrices are what? Exactly same. Only here what we are doing, we are performing 3R3 first and then perform which operation? C3 plus 2C2. Here first we have to perform C3 plus 2C2 and then we have to perform what? 3R3. Means only the matrix are same, only the operations are interchanged. So here we are performing this first operation is what? 3R3. Now here this same operation is second operation. और यहाँ पे जो second operation था ये पहले perform करना है. So let us perform this operation first and later on, and after getting result we have to observe what is our conclusion from example number 5 and example number 6. So already we have considered this matrix. Now we are performing this operation on the element of third column. So don't disturb to element of first and second column here. 1 2 3 keep it as it is, minus 1 1 3 keep it as it is. Now we are performing operation on third column. Observe the element of third column. Here we are taking its addition with 2 multiple of C2, means corresponding element of we are using corresponding element of what? Second column, and we are multiplying to second column by 2 and take its addition with C3. So multiply by 2, here we'll get minus 2 plus 3 will be equal to 1. Then multiply by 2, 2 plus 0 will be equals to 2. Multiply by 2, 6 plus 2, sorry, if I am multiplying here by 2, 6 plus 1 is what? 7. In this way we have performed this operation on the element of third column. Now second operation is 3R3. 3R3 means we are multiplying to the element of third row by 3. Let us see what we'll get if we are performing this operation on element of third row. So keep element of first row as it is, second row also as it is, multiply to the element of third row by 3. See what we'll get here, 9, and if I am multiplying here by 3 we will get 21. Now this is the new matrix which you are getting in question number 6, and this is the new matrix which you are getting in question number 5. Now question is, what do you conclude from example 5 and example number 6? What is our conclusion? That two matrices are what? New matrices. That's why we can say that from example 5 and example number 6 we conclude that new matrices are equal matrices. Now see the question number 7. In this question, one matrix is given to us and using suitable transformation we have to convert it into upper triangular matrix. Already we have seen the definition of upper triangular matrix. When we can say that matrix is upper triangular if all the elements below the diagonal elements are 0. So these are diagonal element, and how many elements are there below this diagonal element? Only one element, that is 3. If we are able to convert that element into 0, then we can say that matrix is what? Upper triangular matrix according to definition. What is definition? All the element below the diagonal elements are 0. These are diagonal element, and below this diagonal element how many elements are there? Only one element, 3. And if all the element below the diagonal elements are 0, matrix becomes what? Upper triangular matrix. Means our aim is simply to convert these 3 into what? 0 using suitable transformation. Suitable transformation means either we are able to use row transformation or we are able to use column transformation. Now if we are performing operation on row, let us see what we'll get. This is the element of R2 and we have to convert it into 0. What is the element here? 3. We have to convert 3 into 0, means from 3 we have to subtract 3. If we are using corresponding element of R1, so if we are multiplying here by 3, easily we will get 3 here. And if we are performing operation on what? Column. So we have, our operation is on first column, so we have to use corresponding element of what? C2. तो यहाँ पे 3 लाना थोड़ा सा difficult है. We are able to convert 4 into also 3, but more efforts we have to take. That's why we are giving priority to apply what? Row transformation here. So our operation is on what? R2 here. We have to convert this element into 0. So since operation is on R2, we have to use corresponding element of any other row. But which is the other row here? Only one row is there, remaining row is R1. So here to get 3, we are multiplying to R1 by 3. And if we are taking difference, then 3 minus 3 will become what? 0. So let us perform this operation on element of R2. Since operation is on R2, so keep the element of R1 as it is, means 1 2 as it is. Now observe this operation very carefully. Operation is on R2. we are using corresponding element of R1. We are multiplying to R1 by -3 and I take addition with what? R2. चलो ये R2 के element है, operation is on R2, multiply to R1 by -3. -3 plus 3 will become 0. Multiply by -3. 2 into -3 is -6. -6 plus 4 will be equals to -2. Now here we can observe that these are diagonal element and the element below the diagonal element is 0, means we can say that this is upper triangular matrix. So this is upper triangular matrix. In this way we have converted this matrix into upper triangular matrix. Now observe the example number 8. In this example number 8, one matrix is given to us which we have denoted by A, and question is convert this matrix into identity matrix. Which are the element of identity matrix? 1 0 0 1, means we have to convert this matrix into identity matrix using row transformation. So here it is given to us that using row transformation we have to convert it into identity matrix, means operations should be performed only on the rows, not on the columns. Okay, well, now already here one first required element is 1, already here 1 is there. So remember some steps here. तो पहले ये element मिलने चाहिए. This will be our first step whenever we are performing रो ट्रांसफॉर्मेशन. चलो 1 और 0 चाहिए हमें फर्स्ट कॉलम में, ऑलरेडी यहाँ पे 1 है. अभी यहाँ पे क्या चाहिए हमें? 0. वाई वी आर फॉलोइंग दिस स्टेप्स? क्योंकि जो एलिमेंट हमें मिला, समझो यहाँ पे 0 मिला, तो ये बाद में डिस्टर्ब नहीं होना चाहिए while converting, while getting another element. So that's why you have to follow these steps. Okay, so here 1 is already there, here we will require 0. So this is the element of R2, means our operation is on R2. Now this element we have to convert it into 0, means we have to subtract 2 from 2 so that we will get 0. Now whenever we are taking addition or subtraction, we have to use corresponding element of other row. Which is the other row? Here only one other row is there, that is R1, and to get 2 here we have to multiply by 2, and 2 minus 2 will become what? 0, means we have to take the subtraction. Operation is on R2, so keep the element of R1 as it is, 1 minus 1 as it is. Now perform this operation on R2. Our operation is on R2, but we are using corresponding element of R1 and we are multiplying to R1 by what? -2. Multiply by -2. -2 plus 2 will become 0. Multiply by -2. -2 into -1 is +2, and 2 plus 3 will be equals to what? 5. Now here we have got 0. Now next step is to get 1 here. So this is our second step, to get 1 here. Means here we will require 1. But if you'll observe here, all the element of this row, instead of this element, remaining elements are 0. So better way, we are multiplying to R2 by 1 by 5, means in short we are dividing to R2 by what? 5. Multiplying by 1 by 5 means divided by 5. Let us see what we'll get. This is our second operation, that multiplying to the element of row by non-zero real number, non-zero scalar. And here what is our scalar? What is that real number? 1 by 5. So operation is on R2, so keep element of R1 as it is. Now we are multiplying by 1 by 5 to all the element of R2. Multiply by 1 by 5, 1 by 5 into 0 is 0. 5 into 1 by 5, 5 will get cancelled 1. In this way we have got our second element, second required element also. Lastly here we will require 0, means here we will require 0 to convert this matrix into identity matrix. To get 1 here, sorry, to get 0 here, our operation should be on what? R1. So what is the element here? -1. If we are taking its addition with +1, we will get what? 0. Already there is 1 in R2, means we are taking its addition with what? R2. And whenever we are taking addition or subtraction, that addition and subtraction can be taken with what? Non-zero multiple of corresponding element of other row. Here which other row we are using? R2, and here non-zero multiple, nothing is the multiple, means 1 is always there, isn't it? So now after performing this operation on R1, let us see what we'll get. We are taking addition of R1 and R2. 1 plus 0 is 1, minus 1 plus 1 is 0. So now operation is on R1, so keep the element of R2 as it is. In this way we have converted this matrix into identity matrix. So here we can say that this is identity matrix. and this completes the solution of this example. Now see the example number 9th. In this example, one matrix is there which we have to convert into upper triangular matrix by suitable column transformation. Column transformation means whatever may be the three operations of elementary transformation we have to perform on what column. So we have considered one matrix. Since we have to convert this matrix into upper triangular matrix, so you should have to know the definition of upper triangular matrix. When we can say that matrix is upper triangular, if all the elements below the diagonal elements are 0. These elements are nothing but what? Diagonal element. And how many elements are there below this diagonal element? 3 elements are there. If we are able to convert these 3 elements into 0, we can say that matrix will become what? Upper triangular. And all these operations we have to perform on column. So let us use the operation on column. So first, so see, we have to convert these 3 elements into 0. So first we are converting this 2 into 0. 2 is the element of which column? First column, means our operation is on first column. First operation is on C1. So if you'll observe here, element of C1 is 2. Now whenever we are, so from 2 we have to subtract what? 2 to get 0, isn't it? So whenever we are performing operation on column, we have to use corresponding element of any other column while taking addition or what? Subtraction. So here if we are using corresponding element of second column, let us check, is it possible to get 2 here or not? What is the element here? 1. Because operation is on C1, means we have to use corresponding element of C2 or C3. If we are using corresponding element of C2 and if we are multiplying here by 2, so we are able to get 2 here. So we have to multiply 2 C2 by what? 2, and later on we have to take what? Subtraction to get 0. Means if we are performing this operation on C1, we will get what? 0. In the same way, now we are not able to perform 2 operations parallelly on C1. So now later on we will see how to get 0 here. Now again here also we will require 0. This is the element of second column, means our operation is on C2. Now, which is the element of C2? 2. Whenever we are performing operation of C2, we have to use the corresponding element of other column. So here other columns are C1 and what? C3. So here 4 is there, isn't it? So here is it possible to get 4? Yes, here we are able to get 4 here if we are multiplying to the element of second column by what? 2. If we are multiplying here by 2, means we will get 2 into 2 will become what? 4. Isn't it? And this is our second operation, multiplying to the element of column by non-zero scalar. So here we are performing second operation of elementary transformation. Parallelly we are performing third operation also, which adding or subtracting. So if we are subtracting C3 from it, here after multiplying by 2, here we will get 4, and from 4 if we are subtracting 4, we will get what? 0 here. So let us perform this operation on C1 and C2. So let us see what result we will get here. First we are performing operation on what? C1. So this is our operation on C1. We are using corresponding element of C2 and we are multiplying to C2 by what? -2. Multiply by -2. -1 into -2 is 2. 2 plus 1 is 3. मल्टीप्लाई बाय -2, -2 प्लस 2 विल बिकम 0. यहाँ पे 0 चाहिए था, इसीलिए हमने ये ऑपरेशन किया है. अगेन मल्टीप्लाई टू C2 बाय व्हाट? -2. -2 into 2 is -4. -4 plus 3 will be equal to -1. In this way we have performed this operation on element of C1. Now perform this operation on C2, means multiply to C2 by 2 and subtract C3 from it. Multiply by 2, we will get -2. -2 minus 2 will become what? -4, because we are subtracting C3 from it. Multiply by 2, so here we will get 2. 2 minus 3 will be equal to -1. Multiply by 2 will get 4. 4 minus 4 will be equal to 0. There is no operation on C3, so keep the element of third column as it is. In this way we have got 2 elements. Lastly we have to convert this element into 0. Now to convert this element into 0, we have to use the corresponding element of C3, because C2 we cannot use because 0 is there. 0 is not helpful to convert it into 0. This element into 0 means definitely here we have to make the use of what? Which column? Third column. But in this case here if you observe, this element is 3. तो यहाँ पे 0 लाने के लिए हमें C3 का यूटिलाइज करना है. तो ऑलरेडी हमें C1 में यहाँ पे 0 मिला है, तो ये 0 डिस्टर्ब नहीं होना चाहिए. while converting this element into what 0, तो पहले क्या करना पड़ेगा, इसे डिस्टर्ब नहीं होना चाहिए, इसलिए यहाँ पे पहले 0 चाहिए हमें, तो पहले यहाँ पे 0 लाएंगे, नहीं 0 लाया तो क्या हो सकता है ये भी डिस्कस कर लेते हैं. सो हियर विच ऑपरेशन वी हैव टू परफॉर्म to get 0 here, which operation we have to perform? What is the element here? -1, and we have to, here we have to use C3, means we have to use what? 4. तो यहाँ पे पहले 4 लाना पड़ेगा. C1 को अगर हमने 4 से मल्टीप्लाई किया तो यहाँ पे -4 आएगा और -4 + 4 यानी C3 ऐड करना पड़ेगा, so that we will get what? 0 here. If we are performing this operation on C1, तो ये पूरे C1 पे ऑपरेशन परफॉर्म करना पड़ेगा. So let us see what we will get. So perform this operation on C1. Multiply here by 4. 4 into 0 is 0, but 0 plus 3, because we have to add C3. So 0 plus 3 will become what? 3. Means this element is disturbing. So that's why first we will require 0 here. Isn't it? अगर यहाँ पे 0 होता था तो क्या होता था? चलो यहाँ पे 4 से मल्टीप्लाई करो. 4 into 0 is 0, and 0 plus 0 will be equal to what? 0. Means this element does not changes. For that purpose, first we will require 0 here. To get 0 here, our operation should be on C3. Operation should be on C3, and to convert it into 0 we have to use corresponding element of what? C2. So what is the element of C2 here? -1. If we are multiplying to it by 3, so here we'll get -3, and -3 plus 3 means we have to take the addition here to get 0. So let us perform this operation on element of third column. So here keep element of first column as it is 3 0 -1. Keep element of second column also as it is. Now we are performing this operation on C3, so we are multiplying to C2 by 3 and take its addition with C3. Multiply by 3. -4 into 3 is -12. -12 plus 2 is -10. Again multiply by 3, so -3, here we'll get -3. -3 plus 3 will become 0. So multiply here by 3. 3 into 0 is 0. 0 plus 4 is what? 4. Now perform that operation. Which operation? 4C1 plus C3 to get 0 here. So let us see what result we will get here if we are performing this operation on element of first column. So first multiply to C1 by 4 and take its addition with C3. Multiply by 4. 4 3s are 12. 12 minus 10 will be equals to 2. Multiply by 4. 0. So 0 plus 0 will be equal to 0. Multiply by 4. We will get -4. -4 plus 4 will become 0. Keep remaining element as it is. -4, -1, 0, -10, 0, 4. And here we can observe that all the elements below these diagonal elements are 0. Means we can say that this is upper triangular matrix. This is upper triangular matrix. Okay, in this way we have completed all the example from this exercise. Remember that whenever we are converting this matrix into upper triangular matrix, may be possible answer may varies. When we can say that it is upper triangular, all the element below the diagonal elements are 0, means we can say that it is upper triangular matrix. But while converting this matrix into upper triangular matrix, may be possible that this operation may changes. कोई अलग टेक्निक यूज करके इसे अपर ट्रायंगुलर में कन्वर्ट करेंगे, या ऑपरेशन चेंज हो गए तो ये एलिमेंट भी थोड़े बहुत क्या हो सकते हैं? चेंज हो सकते हैं, यानी आंसर मे गेट वेरी पर्सन टू पर्सन हियर, इजंट इट? एंड इफ सेम ऑपरेशंस आर परफॉर्म देन डेफिनेटली आंसर डज नॉट चेंजेस. लेकिन ऑपरेशन में थोड़ी बहुत चेंज हो गया तो आंसर मैच नहीं करेगा, आपका जो लास्ट पेज पे दिया हुआ आंसर है उससे मैच नहीं करेगा. सो रिमेंबर दिस थिंग. सो इन द नेक्स्ट वीडियो वी विल स्टार्ट द नेक्स्ट आर्टिकल फ्रॉम दिस चैप्टर. सो इफ यू आर न्यू ऑन चैनल, subscribe the channel and hit the bell icon.